Hello everyone, this is Tiger and I will just try to explain to you the questions in the calculation competition that lots of you are making some mistakes in, or like basically starting from the intermediate questions to the harder questions in our calculation competition year 6. So let's just start with which question is this? Let me take a look. This is going to be the whatever. I think this is the 71st question. Let's start from the 71st question and we'll talk about all the questions after this, all right? So in this question here, we have 47 times 201. Basically, we just need to make use of the multiplication technique, which is by making use of the distributive law of multiplication, where we can split 201 into 201. So now we are able to multiply 47 to each and every term within the brackets. So we have 47 times 200, adding 47 times 1, which is essentially 47. So what we have is 9,400, adding 47. So the answer is going to be 9,447. All right, so this is question 71. Next, let's move on to question 72. So in question 72, we use a very similar technique right here. So it says that 36 multiplied by 99. And also, we can still use the distributive law of multiplication, but this time we are writing 99 as 100 take away 1 in brackets. And after doing that, of course, I can again apply the distributive law, which I'm multiplying 36 with every term inside the brackets. So first of all, I have 36 times 100, and then don't forget the minus sign in the middle. So it's not an addition anymore. It is, well, taking away 36 multiplying 1. So what we get is 3,600 take away 36, and that's just going to be 3,564. All right, so now let's move on to the 73rd question we have. Now, in this question, it's asking you what is 5.99 multiplied by 7, which still we can use the same technique, the distributive law. And this time we write 5.99 as 6 take away 0.09. That multiplied by 7. And the answer is going to be, well, 7 multiplying each and every term within the brackets, just like the previous two questions. So we have 6 times 7 take away 0.01 times 7, which is 42 take away 0.07. And that would be equal to 41.93. All right, so the next one's going to be the 74th question. Wow, so this is using a different technique now. So 88 times 125. First of all, in this question, you are required to know the number pair 8 and 125, which multiplies to 1000. So after knowing that, we can see that 88 can essentially be broken up into 8 times 11. And that multiplying 125 would essentially allow us to use the commutative law of multiplication to calculate 8 times 125 first and 11 next. So now I will be able to multiply 8 and 125. That makes 1000. That multiplied by 11 is equal to 11,000. All right, so that's the answer to this question. And well, let's move on to the next one, the 75th question. So 25 times 28. Again, it requires you to remember a number pair here, which is 25 and 4. So as long as you see 25, you can relate it to 4, where these two numbers, they multiply to 100. So we can see that now we have the 25, and of course, we will be able to break 28 up into the product of 4 and 7. So the calculation becomes 25 times 4 times 7, which 25 times 4 is 100. 100 times 7 is just going to be 700. So that's the answer to this question. And now let's move on to question number 76. So in this question right here, well, it is slightly more complicated than the ones before because we are making use of different rules in this question. So first of all, you can see that I have two numbers, two decimals essentially, added up inside some brackets, and that is multiplied by 48. So the first step to do is, the first step to do is just to multiply the 48 to each and every term within the brackets. So I've got 1.25 multiplying 48, adding 2.5 multiplying 48. And just like previously, we know that 125 and 25, these are numbers which are associated to the number pairs. We know that 125 times 8 is 1000, where 1.25 is 125 divided by 100. So we can write it as 125 times 48 divided by 100. And as for 2.5 multiplying 48, it's just the same. So we can write it as 225 multiplying 48 divided by 10. And next step will be trying to split a factor of 8 out of 48 right here. And for the second part, split a factor of 4 out of 48 right there. So I have 125 times 8 times 6 divided by 100, adding 25 times 4 times 12 divided by 10, which means that this is going to be 1000 divided by 100 times 6, because we can essentially change the order of calculation according to the commutative law. And then the second part is 100 times 12 divided by 10, or actually I should write 100 divided by 10 first. That would be easier to calculate, and multiplying 12. So I have 60 in the first part, adding 120 in the second part. So altogether, that's going to add up to 180. All right, so that's the question. That's the answer to this question 76. All right. And for the next one, 37 times 21. So here you need to know another number pair, which is 37 times 3. 37 times 3 is going to make a product of 111. So now we have the 37, we just need to try to split a factor of 3 out of 21. So we know 21 is 3 times 7, where the calculation becomes 37 times 3 times 7. So that's 111 times 7, which is 777. All right. And then the next question, what is it? I think it's question 78, perhaps. Anyways, I have lost track of the numbers already, so don't worry about it. Let's just move on. So in this question, you can see that the two multiplications here both have a multiplier of 157. And when we see some common multipliers in different multiplications that are added to each other or subtracted from each other, what we need to do is to extract the common multiplier, 157. And that can be multiplied to the sum of 28 and 72. That's like the inverse application of the distributive law. So we have 157 times 100, and that is going to be 157 hundredths, and that's the answer. All right. So let's just move on to the next question. So this is a very similar one. You can see that in both multiplications, they have a common multiplier of 4.72. So what we need to do is to copy down the common multiplier, 4.72, and multiply that by 6.7, adding the 3.3. We know that what's in the brackets adds up to 10. So the calculation becomes 4.72 times 10, which is going to be 47.2. All right. And moving on to the next question. Well, even if we have 3 different calculations right here, it doesn't really matter. It doesn't really matter. We will just need to copy down the common multipliers too. And then that will be multiplied to 2.39, take away 0.61, take away 0.78. All right. So the next step is 7.2 multiplying whatever is in the brackets. Now we can see that 0.61 and 0.78 are both taken away from 2.39. So we might just combine these two together first and see what's the total that is taken away. So 0.61 adding 0.78 is going to be 1.39. So basically what's in the brackets is going to be 2.39 take away 1.39. So we don't need to do the calculations one by one. We will just need to calculate what's the total that needs to be taken away and then take that away from the original number, 2.39. So obviously that's going to be a 1. So the answer is 7.2 times 1, that is 7.2. All right, so that's how we finish this question. And then moving on to the next one. So this one is looking a little bit different because I have 5.6 in my first multiplication, but 0.56 in my second one. Now we need to know one thing, that in a multiplication, if I am expanding one of the multipliers by 10 times, that's how I get 5.6, right? So that I can share a common multiplier with the first multiplication right here. And what happens to the other multiplier if I want to let this multiplication keep the same value? So what I should do is to divide the other multiplier by 10 to neutralize the multiplying 10 in the first step. So what we're doing here is 5.6 multiplying 28. And of course, we still have our first multiplication, which is 5.6 times 72. And those two added together will be the answer. So the next step is to extract a common multiplier. Now we have 5.6 and multiply that by the total of 72 and 28, which apparently sums up to 100. So we have 5.6 times 100, and that is going to be 560. Okay, so the next question is really about how you can relate the different multipliers together. So now we can see that 63 times 278 is about 70,514. And it's asking you what is 175.14 divided by 12.6. So first of all, let's just try to write this, or write the first equation as the second equation, like a division. So we can see that 175.14 is definitely related to 17,514 right here. Where 12.6, let's look at 12.6. Is it more related to 63 or is it more related to 278? It is definitely more related to 63 because 126 is double 63, right? So we can just try to rewrite this first equation as 17514 divided by 63. 63, and that's equal to 278. And now let's see what changes do we need to turn the first calculation into the second one. So first of all, I'm dividing the dividend 17,514 by 100 to get 175.14. And the next step, I am dividing the divisor 63 by 5 to get 12.6. So basically, you can just try to divide 63 by 12.6 to find the relationship in there. So the last step is we know that the quotient is going to be directly proportional, or basically doing the same operation as the dividend or the first number in a division. So that's going to be dividing 100. But it's going to do the exact opposite of the divisor, which means that if the divisor is divided by 5, then the quotient will be multiplied by 5. So essentially, 278 would be dividing 100 and multiplying 5, which is equivalent to dividing it by 20. And of course, if you find it a little bit difficult to divide 278 by 20, you can divide it by 2 first, and then divide it by 10. So after dividing 278 by 2, we get 139. And after dividing it by another 10, what we have is 13.9 as the answer. All right? Okay. So let's just move on to this question right here. I believe it's the hardest question, it's the last question of the, the first intermediate session, or the second last one. Not much difference right there. Let me just take a look. I think probably it's still not the second last one yet, but we just have a few questions left. Anyways, so now we are given the calculation 52 times 12 is 624, and we want to find 52 times 13. So we know that multiplication essentially means adding the same number for a few times, right? So 52 times 13 means I have added one more of the 52 on top of 52 times 12. Therefore, if I want to find 52 times 13 according to 52 times 12, I just need to add another 52 to the product of 52 times 12. And that's going to end up with 676 as the answer. All right, so that is the answer to this question. And then for the next one, wow, the next one is even easier. So 27 times 84 is 2,268. And we want to find 54, And we want to find 54 times 84. Which means this is unchanged. And this is multiplied by 2. So if one of the multipliers is multiplied by 2 and the other is unchanged, or I'll just put an equal sign here, the product is definitely also going to be multiplied by 2. All right, so that's just going to be after multiplying 2, it would be 4,536. All right, so that's going to be the answer to this question, 4,536. All right. And let's move on to this time. I believe it's really the last question of the first section we have here, the intermediate question section. So, well, again, we have a big number, 17,232 divided by 24, that's 718. And it's asking you what is 72 times 718. So just like previously, we are still trying to rewrite this equation such that it becomes a similar format to the second one. So of course, I'm just going to rewrite it as a multiplication, and it will become 24 times 718 equals 17,232. And let's compare this to 72 times 718, okay? So we can see that 718 remains unchanged, and 72 is 3 times of 27, which means the quotient, the product should also be 3 times the original product. So 17,232 multiplying 3, that's equal to 51,696. So that's going to be the answer to this question. All right, so that's everything for the intermediate sections.